Mars, the red planet, a celestial neighbor shrouded in mystery, captivating our imaginations for centuries. Today it stands as a barren world, its surface a desolate expanse of red dust and ancient volcanoes. But beneath this harsh exterior lies a tantalizing possibility, the potential for life, for a second home for humanity. For decades, scientists and dreamers alike have envisioned transforming Mars from a cold, arid desert into a habitable world, a process known as terraforming. It's a monumental task, fraught with challenges, but the potential rewards are immense. Imagine a future where humans walk freely on Martian soil, breathing Martian air, their cities glittering under a pink-hued sky. This dream is fueled by scientific possibility. Mars possesses key ingredients for life: water ice locked beneath its surface, carbon dioxide frozen in its polar caps, and sunlight to power a new ecosystem. The challenge lies in unlocking these resources, in kickstarting a chain reaction that will transform Mars from a hostile environment into a vibrant, life-sustaining world. The journey to terraforming Mars is not just about engineering a planet, it's about pushing the boundaries of human ingenuity, confronting ethical dilemmas, and ultimately redefining our place in the cosmos. It's a journey that will test our limits, challenge our assumptions, and perhaps reveal our greatest strengths as a species. Transforming Mars into a habitable world begins with its atmosphere. The Martian atmosphere is the first and foremost barrier to making the planet suitable for human life. Currently, the Martian atmosphere is thin, about 1% the density of Earth's, and composed primarily of carbon dioxide. This thin layer of gases is insufficient to support human life, or even liquid water. This thin atmosphere offers little protection from harmful solar radiation, and can't support liquid water on the surface. Without a thicker atmosphere, any water would quickly evaporate or freeze. The key to terraforming Mars lies in thickening its atmosphere and warming the planet. By increasing the atmospheric pressure and temperature, we can create conditions more favorable for life. One proposed method is to release greenhouse gases, trapped in the Martian soil and polar ice caps, into the atmosphere. These gases, once released, would act to trap heat from the sun. These greenhouse gases, like carbon dioxide and water vapor, would trap heat from the sun, raising the planet's temperature and increasing atmospheric pressure. This process is similar to how greenhouse gases warm Earth. This process could be accelerated by strategically directing asteroids or comets to impact the Martian surface. These impacts would not only release additional greenhouse gases but also deliver essential volatiles. These impacts would release vast amounts of greenhouse gases and volatiles, further thickening the atmosphere and potentially delivering water to the planet. Water is crucial for any form of life as we know it. As the atmosphere thickens and temperatures rise, water ice beneath the surface could melt, forming rivers, lakes, and eventually oceans. This would drastically change the Martian landscape. This would create a more Earth-like water cycle, further contributing to a denser, more habitable atmosphere. A stable water cycle is essential for sustaining life and maintaining ecological balance. However, this process is not without its challenges. The journey to make Mars habitable is fraught with scientific and engineering hurdles. Mars lacks a global magnetic field like Earth's, which protects our atmosphere from being stripped away by solar wind. This absence makes it difficult to retain a thick atmosphere over long periods. Overcoming this obstacle is crucial for long-term atmospheric stability and ensuring the success of terraforming efforts. Without a solution, any atmosphere we create could be eroded by solar winds. Solutions like creating an artificial magnetic field or utilizing natural features on Mars to shield the atmosphere are being explored, highlighting the ingenuity required to engineer a planet. These innovative approaches could pave the way for future human colonization of Mars. The success of terraforming Mars hinges on our ability to create a stable and long-lasting atmosphere. This is no small feat, as it involves not only generating the right mix of gases, but also ensuring that these gases remain in place over extended periods. While releasing greenhouse gases can initiate the process of atmospheric thickening, maintaining this atmosphere over time presents a significant challenge. Greenhouse gases, such as carbon dioxide and methane, can help trap heat and warm the planet, but they must be continuously replenished and managed to sustain the desired atmospheric conditions. Unlike Earth, Mars lacks a global magnetic field, a crucial component in protecting a planet's atmosphere from the relentless onslaught of solar wind. Earth's magnetic field acts as a shield, deflecting these charged particles and preventing them from eroding the atmosphere. Solar wind, a stream of charged particles constantly emanating from the sun can strip away a planet's atmosphere over time, as evidenced by the fate of Mars's own ancient atmosphere. Billions of years ago, Mars had a much thicker atmosphere, but without a magnetic field it was gradually stripped away by solar wind. To ensure the longevity of a terraformed Martian atmosphere, we need to find ways to shield it from solar wind erosion. This involves innovative engineering solutions and advanced technology to create protective measures that can withstand the harsh conditions of space. One ambitious proposal involves creating an artificial magnetic field around Mars. This would mimic Earth's natural magnetic shield and provide a similar level of protection against solar wind. This could be achieved by generating a powerful magnetic field using a network of superconducting rings placed in orbit around the planet. These rings would generate a magnetic field strong enough to deflect solar wind and protect the atmosphere. Another approach focuses on utilizing natural features on Mars to provide localized magnetic shielding. Certain regions of Mars still exhibit remnants of ancient magnetic fields which could be harnessed to protect specific areas. For instance, the Hellas Basin, one of the largest impact craters in the solar system, exhibits remnants of a localized magnetic field. This area could serve as a natural starting point for creating protected zones on Mars. Strategic placement of atmospheric generators or reflectors in such regions could potentially enhance and extend the reach of these natural magnetic anomalies. By amplifying these existing fields, we could create pockets of protection that help maintain the atmosphere. Protecting a terraformed Martian atmosphere is a complex endeavor, requiring innovative solutions and a deep understanding of planetary physics. Scientists and engineers must work together to develop technologies that can withstand the unique challenges posed by the Martian environment. But the payoff is immense. A stable atmosphere is the cornerstone of a habitable Mars, allowing for liquid water, breathable air, and ultimately, the flourishing of life. Achieving this goal would not only represent a monumental scientific achievement, but also open up new possibilities for human exploration and settlement on the Red Planet. Transforming Mars from a barren world to a life-sustaining one requires more than just a breathable atmosphere. It involves a series of complex and interrelated steps that go far beyond simply altering the air we breathe. It demands a complete ecological makeover, a process that starts with the soil beneath our feet. The Martian soil, or regolith, is the foundation upon which any future ecosystem must be built. Martian soil, while rich in some minerals, lacks the essential nutrients and organic matter needed to support Earth-based life. This soil is not just inert dust, it is a complex medium that must be transformed to support life. One of the initial hurdles lies in dealing with perchlorates, toxic chemicals found abundantly in Martian soil. These chemicals are highly reactive and can disrupt biological processes. These perchlorates pose a threat to both human health and plant life, requiring remediation before large-scale agriculture can be established. Without addressing this issue, any attempt to grow food would be futile. Solutions range from introducing perchlorate-eating bacteria to using chemical processes to neutralize these harmful compounds. Scientists are exploring various methods to detoxify the soil, making it safe for cultivation. Once the soil is deemed safe, the next step involves enriching it with the necessary nutrients and organic matter. This is a crucial phase as the soil must be fertile enough to support plant growth. This could be achieved through various methods, including composting Martian regolith with organic waste. Composting not only adds nutrients but also improves soil structure and water retention. Introducing nitrogen-fixing bacteria to enhance fertility is another strategy. These bacteria convert atmospheric nitrogen into forms that plants can use, enriching the soil naturally. Additionally, deploying genetically modified organisms specifically engineered to thrive in Martian conditions can accelerate the process. These organisms are designed to withstand the harsh Martian environment and make the most of its limited resources. Imagine vast fields of genetically engineered crops, specifically adapted to thrive in Martian soil and utilize its available resources. These crops would be a testament to human ingenuity and adaptability. These crops would not only provide sustenance for future Martian colonists but also contribute to oxygen production and carbon dioxide sequestration, further enhancing the planet's habitability. They would play a dual role in both feeding the population and maintaining the atmosphere. However, cultivating a Martian garden goes beyond simply planting seeds. It involves creating a balanced ecosystem where every element supports the others. It requires a deep understanding of the intricate web of life, from the smallest microbes to the complex interactions within an ecosystem. Each organism, no matter how small, plays a vital role in maintaining the health of the soil and the plants that grow in it. Creating a self-sustaining biosphere on Mars is a monumental task, demanding ingenuity, patience, and a deep respect for the delicate balance of nature. It is a vision of a future where humans and nature coexist harmoniously on a new world, a testament to our ability to adapt and thrive in the most challenging environments.